Hi guys, this is O level chemistry, paper 12, November 2022, question 21. Magnesium reacts with dilute sulfuric acid. Reaction is shown. Which changes in the condition will result in the lowest rate of production of hydrogen? Okay, lowest rate. This is the key point here. Lowest rate. Okay, acid concentration. Acid concentration must be low for the reaction to have a low rate. So acid concentration should decrease. So options A and B are correct here. C and D are wrong. So we will continue with options A and B in the table. Solid particle size. Now, if the solid particle size is large, then the reaction would be slower. So A has decrease in it, which is wrong. B has increase in it. So already we have selected B as a correct answer. Let's look at the third column as well. Temperature. So a high temperature favors a high rate of reaction and a low temperature favors a low rate of reaction. So option A again is wrong here and option B is correct over here. All three columns have option B as the correct option, making option B the correct option for this question. Question 22. Carbonates react with dilute acids to produce carbon dioxide. A student uses excess carbonate and 100 cm cube of 0.1 mole per dm cube acid and measures the volume of gas produced at regular time interval. Okay. The result gives line X on the graph. Okay, this is the thick line that we can see. The student repeats the experiment using 50 cm cube of 0.2 mole per dm cube acid while keeping everything else the same. Okay, now what is happening here is that in the first case, we have 100 cm cube of 0.1 mole per dm cube. So 0.1 moles are present in 1000 cm cube. How many moles would be present in 100 cm cube? So this would be 100 upon 1000 into 0.1. This gives us a value of 0.01 moles. So 0.01 moles are reacting in the first case. In the second case, they have said we are using 50 cm cube of 0.2 mole per dm cube. So 0.2 moles are present in 1000 cm cube. How many moles would be present in 50? So this would be 50 upon 1000 into 0.1. No, into 0.2, which would give us 0.01 moles. So we are actually using the same number of moles in both the experiments. And the question has asked us which line shows the results of the second experiment. Okay, so the line is different, obviously, because options A, B, C, and D are all different. But we know that the number of moles of the reacting acid is the same, right? So the volume of gas produced will be the same, which means automatically options A and D are incorrect because they are showing a higher and a lower volume of gas produced respectively. So the correct answers are either option B or C. Now, if you look at option B, it is producing the same volume of gas in a lower time period, and option C is producing the same volume of gas in a higher time period, which means option B is faster than X and option C is slower than X. Now, what could be the reason behind this being faster or slower? Because the number of moles of acid used is the same. This is accounted for by the concentration used. In the first example, we have 0.1 mole per dm cube of the acid. In the second example, we have 0.2 mole per dm cube of the acid. The concentration has increased in experiment 2. If the concentration has increased in experiment 2, that means the reaction would be more quicker, right? So the more quicker reaction here is option B, making option B the correct option for this question. But do remember that if we use a higher concentration of an acid, but the moles are the same, we will end up with the same result, but more quickly. More quickly means lesser time would be spent in achieving a result. So option B is showing exactly that. we are spending lesser time to produce more uh, volume of gas, but the total volume remains the same. So option B becomes the correct option here. Question 23. In the contact process, sulfur is converted into sulfuric acid. A catalyst is added to the reaction mixture shown in the equation. Okay. What is the purpose of a catalyst? Okay, let's before we look at the options. The purpose of a catalyst is to lower the activation energy requirement by providing an alternate pathway for the reaction to occur. So a catalyst provides an alternate pathway, and by providing that alternate pathway, it lowers the activation energy requirement. Now let's look at the options. Option A, to lower the activation energy for the reaction, yes. Option B, to oxidize sulfur dioxide, no. Option C, to reduce the sulfur dioxide, no. Option D, to shift the equilibrium to the right. A catalyst has no effect on the position of the equilibrium. It only speeds up the rate of reaction. So option A is the correct option for this question. Question 24. Which change involves reduction? Calcium carbonate to calcium oxide. Okay, we have calcium ions, which has a 2 positive charge in both. So this is not a redox reaction. Copper to brass. Copper is a metal. Copper and brass is a metal, and brass is a mixture of copper and zinc. So this is not the option. Option C, ethene to polyethane. Here we have a double bond opening up, nothing else happens. There is no oxidation or reduction taking place. Option D, sand to silicon. Now, sand has SiO2 and this is converted into silicon. Silicon, being an element, has an oxidation state of 0, whereas Si in SiO2 has an oxidation state of +4. +4 to 0 is reduction. And they've asked which change involves reduction. So option D is the correct option for this question. Question 25. Under certain conditions, iron reacts with chlorine to form iron 3 chloride. And the reaction is given here. Which statement about this reaction is correct? Chlorine is the oxidizing agent. Okay, let's see. Chlorine has an oxidation state of 0 and it is converted into -1. Iron has an oxidation state of 0 and it is converted into +3. Iron undergoes oxidation. Chlorine undergoes reduction. And they've asked us chlorine is an oxidizing agent. Something that undergoes reduction is an oxidizing agent, whereas something that undergoes oxidation is a reducing agent. So in this reaction, chlorine is the oxidizing agent and iron is the reducing agent. So option A is correct. Option B, iron gains electrons, iron undergoes oxidation, it loses electrons. Iron is reduced, no, iron is oxidized. This is not a redox reaction, it is definitely a redox reaction. So option A is the correct option for this question. Question 26. The equation shows a reaction in the contact process. Okay. Which change would move the position of the equilibrium to the left? Okay, backward. It is supposed to move backwards. Okay, adding more O2. If we add more O2, we are increasing the reactants. This would result in the equilibrium shifting towards the right or towards in the forward direction. So they've asked us what will shift it to the left. So this is wrong. Increasing the pressure. Increasing the pressure favors the equilibrium to the side with the lesser number of moles. Number of moles of reactants are 2 plus 1, which is 3, and number of moles of products is just 2. So an increase in pressure will shift the equilibrium towards the right. This option is also wrong. C, increasing the temperature. Now, this reaction is exothermic as given by the negative sign in the enthalpy value. So, an increase in temperature favors the endothermic side of the reaction. If this reaction is exothermic in the forward direction, it would be endothermic in the backward direction. And that is what is required, the equilibrium shifting to the left. So option C is correct here. Option D, removing SO3 from the reacting mixture. If we decrease the concentration of the products, the reaction would proceed to increase the concentration of the product. And if it moves towards the product side, that means this would cause the reaction to move forward, making this the incorrect option. Hence, option C is the correct option for this question. Question 27. The table shows the pH values of some substances that can be consumed by humans. P, Q, R, and S. Okay. Which statement about these substances is correct? P is alkaline. P has a value of less than 7. So it is acidic. A is wrong. Option B. Q has the lowest concentration of hydrogen ions. Okay. In order for something to have the lowest concentration of hydrogen ions, its pH must be the highest. So the highest pH is that of R. So Q is not the one with the lowest concentration of hydrogen ions. It is R. So this option is also incorrect. C. R can neutralize excess stomach acid. R should be alkaline to do that. And R has a pH of greater than 7, making it alkaline. So option C here is correct. Option D. S has a pH value closest to neutral. Okay, neutral is 7. S has a value of 7.8 and P has a value of 6.6. The difference between 6.6 and 7 is 0.4 and the difference between 7 and 7.8 is 0.8. So the value 6.6 is closer to 7 than 7.8. So S does not have a pH that is closest to neutral, P does. So this option is also incorrect. Hence, option C is the correct option for this question. Question 28. Solution X is added to a solid salt, causing gas Y to be evolved. Gas Y dissolves in water, resulting in a solution with a pH of less than 7. So basically, this is an acidic gas because it has a pH of less than 7. Okay. What are the possible identities of X and Y? Okay. First of all, let's identify gas Y. A says ammonia, that is an alkaline gas. Carbon dioxide in B, acidic. Ammonia again in C, alkaline. Carbon dioxide in D, acidic. So options B and D might be correct. Now let's look at what we have for X. So in option B, it is sodium hydroxide, right? And solution X is added to a solid salt, causing gas Y to be evolved. So the solid salt should be a carbonate. So adding sodium hydroxide to a carbonate does not produce carbon dioxide gas, making option B incorrect. Now let's look at option D, dilute HCl. When you add acid to carbonates, carbon dioxide is produced, making option D the correct option for this question. Question 29. Which substance reacts with dilute sulfuric acid in the preparation of a pure sample of lead 2 sulfate? Okay, now lead 2 sulfate is an insoluble salt. So an insoluble salt is prepared by the action of an acid with a soluble salt. So let's look at the options here. The acid is sulfuric acid so that we get the sulfate ion. Now we need a soluble salt. Option A is lead 2 nitrate. All nitrates are soluble, so this is a soluble salt. Lead foil, that is lead metal. It is not a salt. Powdered lead carbonate. Lead carbonate is insoluble. And powdered lead oxide. Lead oxide is also insoluble. The only soluble option here is lead 2 nitrate, making option A the correct option for this question. Question 30. A pure sample of a salt is obtained by filtration followed by evaporation of the filtrate. Okay. Now we have a soluble salt here and it is prepared by filtration and evaporation. So filtration means that something insoluble should be reacting. So here we would have an acid reacting with an insoluble salt. Okay, which pair of reagents would produce a salt? Copper and hydrochloric acid. Copper will not react with hydrochloric acid because it is less reactive than hydrogen. B. Excess copper to carbonate. Carbonate is insoluble. And hydrochloric acid. This is our requirement. Option B is correct. Option C. Aqueous silver nitrate, soluble, and hydrochloric acid. No, this is a soluble salt reacting with acid. And D, aqueous sodium hydroxide and hydrochloric acid. This is not a salt reacting with an acid. This is an acid-base neutralization reaction. So this is also wrong. So option B is the correct option for this question.